on page 100, topic 18, and the exercises that we're going to do here are 1G, 1I, 2F, 3K. In part 4 we're going to do J, H, and L, and in question number 5 we're going to do H, Q, and T. So square root of 225, we've rewritten it here. We can, two ways to do this. We can break it down into perfect squares. You see, 9 is a perfect square and 25 is a perfect square. 9 times 25 is 225. So instead of the 9, we write 3 squared. Instead of the 25, we write the 5 squared. Square root of 3 squared is 3. Square root of 5 squared is 5. 3 times 5 is 15. Now, if you happen to realize that 225 is 15 squared, then the square root of 15 squared is 15. So either way, you can get 15 as the answer. Realize that it's either 15 squared or break it down into two simpler numbers that are perfect squares. Here we're asked for the cube root of 125. This little 3 indicates a cube root. I've written it here. And instead of 125, I've written 5 cubed. So this cancels this. You can see this is what we learned on page 97. That this number and this number are the same, and here they're the same, and we've got the root sign. Then the answer just comes out to whatever is here, or the a factor right here. So because of the minus sign outside the square root, there's a minus here. This minus is this minus. So the cube root of 5 cubed is 5. And now here it says evaluate with a calculator. This add twice the square root of 7 plus 4 times the square root of 13. So really what we have to do is treat each of these independently and use a calculator. The square root of 7 is 2.64575, and we multiply that by 2, we get this. The square root of 13 is 3.60555. We multiply it by 4, and we get this. When we add the 5.2915 to the 14.4222, we get this. Now, both these numbers here, the root of 7 and the root of 13, are irrational numbers. So I just terminated the number after the number 5, but these are irrational numbers. This is an irrational number, and this is an irrational number, which means they don't terminate and they don't repeat. They just keep on going, like pi or the square root of 3 or whatever. These numbers are irrational. So these are this answer is an approximation to the true answer. Here we're asked to do the cube root of 1,000 and then square it. So we work from inside the bracket to the outside. First of all, convert the 1,000 to 10 cubed. You got to realize. So I'm going to take this 1,000. Instead of it, I'm going to write 10 cubed because it's 10 times 10 times 10, and that's why it's 10 cubed. So now this negates this. These two cancel each other, and we're just left with 10, and the squared here is right here, so 10 squared is 100. So right at this point here, right here, we're applying this rule here from page 97, because this and this are the same, and we just get whatever the number is right here, which I put here. Now, here we have the square root of 5 over 2, square root of 25 over 8. We can combine these two because they're both, the indexes are the same. There's an implied 2 here and there's an implied 2 here. So what I've done is multiply the 5 times the 125 numerators and multiply the denominators together. Get 625 over 16. Now, it helps to know that 625 is 25 squared and 16 is 4 squared. So now I can separate this into the square root of the numerator squared divided by the, I can separate it into the numerator and the denominator. And the numerator is inside the radical sign is a perfect square, and inside the radical sign of the denominator is also a perfect square. Square root of 25 squared is 25. Square root of 4 squared is 4. Now here, in order to simplify this, what we've got to do is get one term for this, combine these two together, and so we got to get a common denominator. So 5/16 plus a quarter. Well, a quarter, if I multiply the top and bottom by 4 here, I get 4/16. So I can add 5 plus 4 over 16, which is 9 over 16. Separate this into the numerator and this into the denominator. Square root of 9 is 3. Square root of 16 is 4. Here I have the numerator and the denominator separated. So what I'm going to do is write one root sign and combine the numerator with the denominator here. And you'll notice that the x's cancel. 2 into 16 goes 8. And then I have, right here, I have 8 to the power 1. When I bring that up, it comes a to the 3 minus 1, and that's why I get a squared. Now, instead of 8, I'm going to write 4, which is a perfect square, 2 squared right here. 4 times 2 gives me the 8. And I'm going to leave the a squared in there. Square root of 4 is 2. Square root of a squared is a right here. And all that's left under the root sign is the number 2. Okay, now here I have 5 times the cube root of 16 and 2 times the cube root of 24. So I've rewritten the problem right here, and now instead of 16 I'm going to write 8 times 2, and instead of 54 I'm going to write 27 times 2. Now why do I do that? Because I know 8 is 2 cubed and I know 27 is 3 cubed. So the cube root of something cubed is whatever the number is right here. So always look, try to see if you can simplify it in that way. So 16 is 8 times 2. 54 is 27 times 2. Right here, instead of the 8, I'm writing 2 cubed. Instead of the 27, I'm writing 3 cubed. Now, the cube root of 2 cubed is 2, and that's why it appears right here. The cube root of 3 cubed is 3, and that's why it appears right here. So I have 10 cube root of 2 minus 6 cube root of 2. And of course that gives me, I could take out the cube root of 2, and the 5 times 2 is this 10 here, and the 2 times 3 is the 6 here. Usually we write the number first and then the root sign second. So it's 4. 10 minus 6 is 4. It goes here, and we've got the cube root of 2. In this case, because we're doing square roots, what we're going to do is look at each one of these numbers and break down the numbers under the square root sign into perfect squares. So instead of 125, I'm going to write 25 times 5 because 25 is 5 squared. So at square root of 25, I can simplify. So break these numbers down if I can find a perfect square, and 25 is 5 squared. Instead of 45, I'm going to write 9 because that's 3 squared. And instead of 20, I'm going to write 4 times 5. This is 2 squared. This is, excuse me for a second. This is 3 squared, and this is 5 squared. So when I take the square root of 25 outside, it becomes the 5. When I take the 9, bring it outside the root sign, it becomes 3. And when I take the square root of 4 and bring it outside the root sign, it becomes 2. So now you see that I have 10 root 5 right here. 4 times 3 is 12 root 5, and 6 times 2 is 12 root 5. I add 10 minus 12 gives me minus 2 root 5. Minus 2 root 5 and minus 12 root 5 gives me minus 14 root 5. So the key thing is when you've got the square root, try to look inside here and see if you can find a perfect square. Now obviously if you take this one here, you can see right away that you can't take the number 4 out, or let's say the number 9 out. You can't take 16 out. The smallest number that you can take out is 25. This is a matter of being more familiar with arithmetic and knowing perfect squares. Okay, here we have the square root of 8x squared minus x root 18 plus 50x squared. So again, what we try to do, instead of 8, I'm going to write 2 times 4. This is a perfect square. Instead of 18, I'm going to write 3 squared times 2. And instead of 50, I'm going to write 5 squared times 2. Probably here I should have written 2 squared to be consistent. Now, square root of 4 is 2, and the square root of x squared is x. So that goes here. All I'm left in the root sign is the 2 here. So I take the square root of 4, it's 2, take the square root of x squared, it's x, and all I'm left with is the root sign here. Here, the x is already on the outside. I take the square root of 3 squared, it's 3. I get minus 3x root 2. And here, I take the square root of 5 squared is 5. Take the square root of x squared is x, and I'm left with a root 2. So then I can factor out the root 2 from each one of these terms, and I have 2x minus 3x plus 5x. This is 2 and 5 is 7. 7 minus 3 is 4, so I have 4x root 2. Okay, so all I'm doing, I'm taking this part here and factoring out what's common, and what's common is root 2. I could have actually factored out the x too and done it that way. I could have factored out the x and root 2x and then said 2 minus 3 plus 5. But I would still obviously get the same answer here. So that completes page 100.